Hello, welcome to this March 2016 Getting Started with CyVerse webinar. I'm Jason Williams. I'm coming to you from Cold Spring Harbor Laboratory in New York. Welcome. We have this webinar on a monthly basis for the 600 or 700 new people that sign up for an account each month. And this is a way for us to answer some of your questions, give you some demos of the materials and the resources and the tools, and really get you started using the platforms. So we hope that you'll be able to stay with us for the next hour and get a little bit of an introduction to the things that you'll need to do at first in order to get started. Before I actually go into the presentation, which is going to be a short intro to the project itself, followed by a couple of quick hands-on demos, I want to just discuss quickly the Adobe Connect technology that we're using for the webinar. One of the most important things is that beneath the screen on your computer there, you should be seeing a question box where you can submit questions at any time. And then off the screen, I can actually see the questions as they come to me. So I'll be looking off screen sometimes just to make sure that there are no additional questions. So please feel free at any time to go ahead and send me those questions. Now on the other column there, you should actually see at the top that there's a download where you can get the slides, and then beneath that there are some links. Finally, on the top of the screen, you're going to see a little button with 4 arrows, so you can actually expand and make this full screen. And that'll be important for the parts of the presentation where I'm using my computer. You'll be able to see things a little bit better if you're following along. Finally, this entire webinar is being recorded, and it will be posted to YouTube shortly after the presentation, so usually within the next day or so. So if you missed anything and you want to go back or even want to share this with your colleagues, you can refer them to the recorded version at that time. Okay, so in order to get started, please listen to this sort of first little bit of an introduction, give you an idea of where the project came from, what are our goals, and that will help you to understand how to use it best, where are the resources for help. Okay, so let's begin. The first thing I wanted to talk about or discuss is actually the evolution of the project, our vision as a project. Our vision is to transform science by making it possible to do data-driven discovery. So the way that we actually do that, our mission, is to design, develop, and deploy a national cyber infrastructure for life science, and of course including training the scientists in its use. Now, as a community, now in 2016, we are made up of more than 30,000 users. We have petabytes of data, and hundreds of publications, courses, and discoveries have been enabled by the infrastructure. Now, many of you may have known us by our previous name. So just earlier this year, we went to this last step in our evolution. We started out as iPlant, which was created in 2008 with the idea of enabling data-driven discovery and cyber infrastructure for the plant science community. Later on, because of the success of the project, we were renewed in 2013, and we started to adopt a title or sort of a mission that was reflective of our larger goals and aims, which is to provide cyber infrastructure for all life science. And so now in 2016, under the new name CyVerse, we really are a platform that's enabling data-driven discovery for the entire life sciences. The key thing for our users also to understand, and that of course we're grateful for, is that this is a project that's funded entirely by the National Science Foundation. So what that means is that we're your colleagues and your collaborators. We have nothing to sell. We don't personally benefit from the products and tools and services we provide, although we of course use them. And so it really means that we are looking to work with our users to solve their problems and provide the resources they need to do their science. It's a $100 million investment, and what that means, I think, for most scientists is that you can actually spend or leverage that investment because these resources are paid for. So you will never log on to the CyVerse website and be expected to pay directly for the services that you are provided with. So in many cases, although we don't purport to be the solution to every single scientific problem or necessity you may have, we can provide a lot of the computational resources that you need. And so we'd like to see the scientists leveraging that, spending more of their money on their actual science experiments and generating the data than worrying about how they're going to manage, store, and analyze those data. Importantly, CyVerse is also open to the entire world. So we realize that science doesn't have borders, and so we have many international collaborations where scientists are able to effectively share and manage their data using CyVerse. Finally, that goes along with this slide, we really do appreciate if you acknowledge us. So you have the opportunity to cite us when you make a publication, when you have a poster. We love seeing our users at conferences and meetings, so we really do want to have a community, and citation is one of those things, so see that website link for more details on that. Okay, so I've used this word a couple times now. What's the definition? Cyber infrastructure. Well, cyber infrastructure, in one sense, is nothing that you're not already somewhat familiar with. It's data storage, software, high-performance computing, and importantly, it's people. And when you take all of those elements and you really organize it into a system, it gives you the power to solve problems of size and scope that otherwise you really couldn't solve. So practically speaking, when you come to CyVerse and when you think about using our cyber infrastructure, you should be thinking about access to platforms, tools, and data sets, storage and compute, and training and support. All of those things are elements of what we as a project endeavor to provide. The other thing that we really want to stress and emphasize, and that our new name reflects, is that we support life science. So plants, microbes, animals, biomedical science, ecology, climate. CyVerse is built for data. And we realize that you as scientists often work in many different domains with many different types of data, you and your collaborators. So it's, we don't want your science to stop where our limitations stop. So we really support the analysis of data, which is common to all of these endeavors. This is a quick look, and I'll be going into a little bit more detail here for the product stack. So in the webinar, we'll be focusing up at the top level. These are the things that you can see, that you can use, the cloud compute, the web interfaces. But at the lower level, we really are an infrastructure. So you're probably used to a platform and you can go in and maybe you submit a bit of sequence data and you press a couple of buttons and you get some type of result. And of course, we do provide that sort of science as a service. But we also have infrastructure at this bottom layer. Now, this is definitely a little bit more technical in how you use it, but for those of you who are biologists / power users, or even computer scientists or other types of information technology engineers who are building systems for biologists, you really actually have the ability to expose and customize many components of the infrastructure. So your flexibility, your ability to really make things custom increases as you go down. Most of us, bench biologists like myself, will want to be operating for the most part up at this top layer. But there are all these products, and there are lots of things you don't see, like authentication, keeping your data secure, being able to search your data, manage it. All of those things are located within that stack. Now, a quick bit of history. It won't take too much time to go too far into the sort of historical things, but it is important to realize that as a platform, we always knew from the beginning with this sort of introduction of the idea of big data and biology as actually being a data science, we always knew from the beginning that it would be a community effort, that we wouldn't just build things of our own accord. Community cleverness was required. And so over the first 1.5, almost 2 years, the project was largely focused on community needs and an assessment of those needs. We still, of course, invite and respond and react to community requirements and requests, but those same priorities that we established at the beginning of our project are still very much the big data drivers within biology. So when you come to CyVerse, you'll find platforms and tools for working with genomic data, including all those listed here, like assembly, RNA-seq, variant calling, etc. But the other key thing is that we're not just about genomic data. So you may have environmental data sets, you may be working with phenotypes and images, phylogenies. All of those different things are necessary in order for you to sort of do these higher level investigations, which often mean combining multiple data types, multiple scientific questions in order to do modeling, in order to do different types of studies. Another key thing about CyVerse as a project is that we are not alone. There are many other projects, some bigger, some smaller, and our goal is to find access for you. So we try to make it such that you don't have to move things around, but that we collaborate with many other projects so that when you need to move from system to system, you have that interoperability with a minimum of pain. And if there are other systems and collaborators and resources, very often you let us know and we can find ways to collaborate with them. Another important thing about our collaborative aspect is that we're made up of multiple institutions. So University of Arizona, University of Texas, Austin at the Texas Advanced Computing Center, Cold Spring Harbor Laboratory, and UNC Wilmington are our organizations that sort of founded the CyVerse project and work today closely. But it even and increasingly spans borders. So the iPlant UK project is itself a collaboration formed by BBSRC. And so I just want to emphasize that it really is an international project. We are very open to the idea of collaboration, and this really just makes it great for our users. Okay, so now let's start to drill down a little bit into the actual pieces of the infrastructure. What are the products and what do you get? Well, we kind of think of ourselves almost as Lego or building blocks, whatever one isn't completely trademark. We have built 85, maybe even 95% of the pieces of the solutions that you need in order to do your science. And then the last 5%, usually that's the part that you want to customize, you want to put together. So we've built many of those pieces, and then we give you the freedom, the ability, sort of the audacity to sort of build new things. And oftentimes we're surprised when users come back and they've pasted the infrastructure together in ways that we didn't know were possible. Doesn't always work on the first try, but often the results are really incredible and advance some great science. So what are some of the pieces? Okay, the first one here is the data store. So I want to say the iPlant data store, but now the CyVerse data store are the resources you need to share and manage data with your lab. Everyone has an initial 100 gigabyte allocation. If you need terabytes of data, that's possible, but you do need to just speak to us, give us a little justification, fill out a form. The data are automatically backed up, and you have an easy way to upload, download, and share those data. I will be showing this in a demo momentarily. The discovery environment is an easy-to-use interface to hundreds of bioinformatics applications. You can use almost any application you normally use at the command line. It's integrated with our data and high-performance computing, and importantly, it's user-extensible, so you can add your own applications. Atmosphere is our cloud computing solution. We'll be seeing that a little bit later in the demo. You're able to spin up virtual machines. I often find that actually many biologists still aren't using the cloud in this sense, so we'll give you a quick introduction and show you some of the benefits to that. The science APIs, primarily Agave, we won't be showing, but this is an example of how power users are able to go in and directly exercise, extend, and use our infrastructure. DNA Subway is for the classroom. If you're interested in teaching and bringing bioinformatics into the classroom, you can use DNA Subway for that. It's a number of bioinformatics workflows that have been made classroom friendly and support hands-on inquiry-based experiments for students. BISC is our image analysis, management, and metadata platform. It works with hundreds of different types of image data and the metadata, so you can do image stitching, geolocation, working in many different sort of dimensions. It's really quite good if you're working with image data. And that is it for sort of the background. So what we're going to do right now is we're going to give you 3 getting started demos to using the infrastructure, talking about how to actually move data around and share it, how to do an analysis using the web interface, the discovery environment, and actually how to get onto the cloud. So with all of these demos, I want to remind you again, please, at the bottom of the screen, you can ask me a question at any time. I love the questions. That's sort of the point of the coming to the live version of the webinar. And also at the top of the screen, those arrows that you see there, that button, you can make it full screen so that when I do the computer demo, as I'm about to do now, some things that may be small and I can't make too much bigger, you'll be able to actually see with a little bit more detail. Okay, so CyVerse Data Store. As I mentioned, the data store allows you to store any type of data that's related to your research. You can move the data between different CyVerse platforms, automate file transfers, and share files with your lab members, with collaborators, and with communities. There are multiple ways to access the CyVerse data store. We're going to show 2 here. One of them, the really easiest one, is called CyberDuck. We're also going to touch on the discovery environment, and we're going to work with the command line. In the discovery environment, you can move smaller files. We recommend that you actually use CyberDuck or iCommands for large files or large numbers of files. There are some size and speed limitations. So by and large, when you want to move large files, we won't be doing it here. The discovery environment is going to be really important for sharing data, and we'll show that later. CyberDuck is really like almost a Dropbox. You can drag and drop files and folders. There's no size limit, and it really has an easy desktop functionality. iCommands, for those of you who are more comfortable with scripting, is a perfect solution for being able to automate your analyses and your data transfers at the command line. And now we're going to go ahead and do a quick demo. All right, so let me first direct you to the CyVerse homepage. It's at CyVerse.org. From the CyVerse homepage, you probably will want to at some point go down to the Learning Center. And in the Learning Center, you see a whole bunch of links to various things that I'm going to demonstrate today, including managing your data. So when you go to the Managing Your Data link, it'll have links to all the downloads. I, of course, during the webinar, don't have time to show you the setup of some of the features, but many of them just require a few moments and you'd be able, on your way to sort of setting up all of these things. So first I'm going to start with CyberDuck, which I already have installed on my computer. CyberDuck is a standalone software tool that is not at all developed by CyVerse. When you first download CyberDuck, you're also going to download one more file from the CyVerse website, which is its profile, sort of a bookmark. There's a pretty simple configuration tool that you're going to use, and then once you've configured, you're just going to double-click to log on. Now, in my experience, this takes about 15 to 30 seconds to actually connect to the CyVerse data store for the very first time. So I'm going to go ahead and let that connect. And while that's connecting, let me just quickly show you back here on the CyVerse Learning Center. In the links here, we talked about data, and here we are down toward the middle here where it says CyberDuck. So if you click on this link on installing and configuring CyberDuck, it'll take you to a wiki page. Got to click once more again because that link has been moved. And it will just take you through the steps of installing or updating CyberDuck. So there's a little bit of configuration, but everything is really in detail displayed for you there. And if you need help, there's also resources. So we'll talk about the help resources later. Okay, now while I was looking at that, my CyberDuck started. And really, what it is almost like a sort of a Dropbox or a connection to a remote server. I cannot zoom in, but you can view this full screen on your Adobe Connect. If I want to move files or folders from the CyVerse data store to my computer and vice versa, it's really just a matter of clicking on a file. So here's a PDF file, a paper, and I can just drag this over to my desktop if that's where I want it to go. And what will happen is I will see a link here, or rather a status in my transfers window. It will take a few seconds and then that transfer will begin. Okay. If I have, let me create a little file on my desktop. Okay, if I had a file or a folder on my desktop and I wanted to drag it into my CyVerse data store, it would really just be a matter of point and drag and drop. So I drag that over there, and then that will be the next thing that is sort of documented in my transfer window. You saw me moving files, but you could just as well go ahead and move folders. The downloads are completed, and then you have the files and folders wherever you have placed them. So it's really quite easy to move files and folders. There are some additional functionalities within CyberDuck that I'm not going to go to really in depth. There are other places within iPlant or within CyVerse besides your home folder, so you can actually directly type those locations in. Maybe we'll see that a little bit later in the discovery environment. But really, that's it. You should be able to move a large amount of files and folders. If you have several gigs of FASTQ files and you need to move them over to CyVerse, you can do that, just drag and drop. So in our experience, moving about 100 gigs on a really good connection should take on the order of about 30 minutes. So you should be able to move files really quite easily between your local system and the iPlant data store. Okay, but what if you prefer to use the command line? What if you have files or folders that are on a server somewhere? Let me show you the next step. So I'm going to go back and minimize CyberDuck. And back on that Learning Center, let's go back a page or two. Actually, here it is in the Manage Data. It mentions the next thing, which is called iCommands. So for iCommands, there is, again, a wiki page that would take you through downloading the iCommands. and you could follow the instructions. We're assuming a little bit of familiarity with Linux. Of course, if you need help, please let us know. I already have iCommands installed on my computer, so I'm going to start them. Let me just choose a terminal that's a little bit easier for you to see. This one I can make a little bigger. Okay, so here is my terminal. Excellent. And from the terminal, if I want to be able to access iCommands, assuming that I've already set everything up with the iinit command, if you were doing this for the first time, it would ask you to enter your configuration details, which are back on the wiki page. For me, I just enter my password. Okay, nothing happens, which is actually good. And if I want to see the contents of my directory, it's very much like Linux. Instead of an ls command, it's really an ILS, hence the word iCommands. We didn't come up with it, but we're using other technology. They also used I. And this is, again, my iPlant, now it's called the CyVerse data store. If I want to bring files down, it's just a command. So, for example, if I want to bring down the VCS folder that I see there, it's called iget, and that will start a download. I'm going to be bringing a directory, so I need it to be recursive. I want to see the progress, be verbose, give me some time information, and then I can do .vcs. I want to go to my desktop. And when I hit enter, you can see that the VCF folder is already created on my desktop. And then after a second, I will start to get notifications of the file transfers happening. It happens to be, looks like I'm on wireless, so it took a few seconds, but essentially it transferred those data. It's a multi-threaded system. These data were small, so it used 0 threads, but again, if you're transferring large amounts of data, this will open up, increase the number of threads, and you can transfer rapidly a large amount of data from one system, a server, or your local computer, wherever you want, back and forth between the data store. So that's really the two things that we emphasize for uploading and downloading data. Next, what I'm going to show you is really more on the sharing aspect. If you go back to the CyVerse homepage, from the CyVerse homepage, you have various links, and what we're going to check out right now is the discovery environment. And I'm just going to scroll down here to where it says launch the discovery environment. Now we're going to talk more about the discovery environment in my demo in just a few moments in terms of actually doing analyses, but for right now we're just going to go ahead and talk about the data aspect. So let me go ahead and log in, enter my CyVerse credentials. Okay. And now I'm logged into the data store. Let me close these windows because it always opens to whatever you're working with previously. This is the discovery environment. I'm going to talk more about this in a moment, but for right now I'm just going to click on this data window. And here I can zoom in just a little bit. And the sort of ID here is like a desktop. So let me click on my home folder, which is my CyVerse username. You'll notice it has a location, so if I was in different locations, remember I mentioned in CyberDuck you could navigate that way. But this is the same files and folders we've been looking at through the command line, through CyberDuck. They're all here. There's a lot of functionality here that I can't go into. For example, I can certainly click on a file and preview the contents of that file. Really large files will be sort of shown to me in sort of several kilobyte chunks, but I can see it's a really nasty looking FASTQ file. Not good data. The file itself is connected to some other data, for example, when it was uploaded, downloaded, the checksum, etc. But let's say I want to share that file. If I want to share a file, an individual file, I can go up here and say create public link. Click on that file here and say go ahead and create. And what it will do is it will create a URL. I can copy that link to my clipboard, and then I could go to that URL and it would start a download as it would for any particular, as you would do on the internet. It would just let me download it. So that's really useful if I want to share an individual file. Whoever has that, they don't need to have any type of iPlant CyVerse account. They can just download it. We wouldn't recommend this for really large files, so something that's several gigabytes will almost certainly break. They won't be able to restart. They'll have to try downloading again. So this is good for smaller things, and it's basically, just ad hoc. Now, the thing about these links is that anybody who has the link can download it, so you wouldn't want to share things that you want to keep secure, because if they share that link, or once they download it, they have it, there's really not very much you could do. Okay, so if you are done with the link and they've downloaded it, or you no longer want the link to exist, you come back to the same panel and you click that little minus delete data link, and that will allow you to delete the link, and anyone using the link again would not be able to access it. Now that, again, let me emphasize, only works for individual files. I can't send a folder that way. If I want to share a folder, or if I want to share really large data sets, the very best way to do that is to go ahead and click on that folder, then go up to share, and then say you want to share with collaborators. Okay, so there I can search for the name of any other CyVerse user. As I type their name, they should come up along with their institutions. So I can click on my colleague's name, and then I can decide what level of access I want my colleague to have. If I give read permission, they'll be able to read the data, they'll be able to perform an analysis, but they won't be able to change anything else. They couldn't write to the file, they couldn't alter the metadata. If I go ahead and turn write, they could actually add to the file in addition to the other things, although I believe they cannot alter the metadata. And if I go to own, they can do everything, including, unfortunately, so you have to be careful, delete the file, move the file. So you would only assign these permissions according to what was the appropriate case in your circumstance. On the CyVerse wiki, there are more details about which each permission entails. It's roughly analogous to the sort of Linux system of permission. So if you're familiar with that, it's very similar. Now, if I want to actually share this, though, I'd click Done, and a notification would go out both to me that the transfer is complete, and to my colleague the next time they log in that something has been shared with them. It usually takes in the order of a few seconds, but what that means is that if you have a terabyte of data and you need to share it with other collaborators, they can have access around the world within a few moments. Okay, if I want to revoke the access, I would come back to the screen and I would just click the X next to that person's name. That would completely revoke. I of course had the option of changing permissions, but if I want to completely revoke, that's how I would do it. So I'm going to close that, and now I think you have a little bit of an understanding of how easy it is to share data within the CyVerse data store. Let me also mark note a couple other things. One, if data are shared with you, they appear in the Shared With Me folder, in a folder that is analogous to the username of the person that is doing the sharing. I'll note that also when you first log in, you may see lots of different folders and files. That's because there's some things that are shared with everybody, regardless of whether you knew it or not. So those things are there. Additionally, there's community data. So there's some data sets that we also share with anybody through that system. You also have trash favorites. So that's essentially somewhat self-explanatory. One final thing that I want to emphasize that's really important, although I can't go into too much depth right now, is that attached to all these files are also metadata. So let me just select an individual file. Okay, so here's a file. And if I go up to Edit and then say I want to edit the metadata, oops, okay, edit metadata, I could go in and I could add data according to the attribute value system. So I could say, this is going to be genus, and I could say, Rosa. I could say, experiment, and I could say time course, whatever type of thing. Now this starts to get tedious, but the point is that you can actually apply these metadata to a file. You at some point reach a stage where you can't name a file experiment 1 underscore date underscore experimental condition, etc. But we can do this programmatically. So number one, there's templates here. So if this was, for example, a bio project on NCBI, there's a specific template with specific metadata terms and help. And additionally, if we have a CSV file that's associated with lots of data, we can't do it here, it's going to be grayed out, but we could apply bulk metadata to individual files. And one of the things that this enables you to do, besides really organizing your project, is if you go up to this search area here, you could not only just search by something simple like I want to search for the name of a genus, but you could actually develop your own rather sophisticated queries. So if I search for that term, which is the name of a genus, it will come back with some results. But if I actually go up to that search funnel, I have a lot more options. So if I wanted anything that had the genus and it was the value Dioscorea, I think it could then search and have more specific queries, and then it pulls up just that one element. If I go up to the metadata and see that it already has that sort of attached to it. This is not a really complex metadata example, but hopefully that gives you the idea. Additionally, back here you can create search terms that are smart filters or smart folders, so that everything that matches your search terms will automatically be deposited into the appropriate folder. So that really is a little bit of an introduction to the data sharing. Hopefully you've seen how to upload data back, download data. You've seen that you can share data. So now let's go back to how to actually analyze the data. If you're somehow following, keep in the discovery environment, we're going to come right back to that. But first, a few slides just to quickly get us into the discovery environment and what we're going to do here. Okay. Okay, so the discovery environment. As I mentioned, the discovery environment is a platform, so you can run almost any bioinformatics application. It's integrated with the data, as you just saw, and also with high-performance computing, and you can also add your own applications. In the data window, we've already covered uploading, downloading public links, share files and folders. Now we're going to talk about apps, which are where the actual bioinformatics applications are. That's where you would go to build an automated workflow, and also you would be able to modify or integrate new applications. I see a question coming through. I'm going to answer that one in just a moment about what file system do we run for the data store. Finally, in analyses, you can go and monitor the job status, see results. You can cancel or relaunch jobs, and you can also get a detailed job history. Okay, so we're going to do a quick demo. We're going to take some unaligned DNA sequences in FASTA format, and we're going to create a multiple alignment. So we're going to view the data, use the app, and then monitor the progress of the job. Okay, so here we are back in the discovery environment, and a question came through to me, which was, what kind of file system do you run in the data store? So the data store itself is using a technology called IRODS, Integrated Rule-Oriented data structure, data system, this grid data computing. So it's a little bit more complicated than what you would say a Linux file system is, but it really is basically on some level like a Linux file system. So we use similar ideas of here's how directory structures are laid out. We use similar ideas of how permissions go through. If you have a more specific question as to how that technology works, or whether you would or would not be able to do something, please ask me. Other than that, I could also direct you to the documentation on the data store. That would give you some ideas. There may be questions. Can I mount the data store? Can I do various things? If you have a more specific question, I can perhaps go into more detail. So just let me know. I'm going to continue with back on the discovery environment. Okay, so back on the discovery environment, I'm going to go into data. I'm going to take a look at some data that we're going to use for our demo. So let me go into community data. And from here, I'm going to select iPlant training. Then DE walkthrough. And finally, within this folder, there is a file that I'm looking for called DE sample plants. And as you could see when I click on it, it's just a FASTA file of some unaligned DNA sequence. So this is going to be the input for the demo. Okay, we chose a really simple application. All right, so it's there. I'm going to close this. And now what I'm going to do is click on the Applications menu. Okay, so in Applications, we have a catalog of about 400 different bioinformatics applications. At the top, my workspace are my favorite apps, things I'm working on, workflows, etc. But mostly we want to focus on these public applications. If I scroll down, I'll see that they are categorized into some categories by topic, like NGS, aligners, etc. And I could see what aligners there are in the moment. There are different versions of things. You may have some that have ratings as to whether certain users have found them successful or easy to use, or etc. But what I'm going to do is I'm going to go ahead and search apps. I'm going to search for muscle, because that's the app that we're using in the demo. And what it should come back with is a listing. Now, sometimes there are more than one app. Happens to be that I know the favorite app, 3.8.31, is the one I want to use. There sometimes are older versions of applications that are inaccessible, and they might be in red. There might be apps that are listed as DAS HPC, so they're running directly in an HPC system, so they might be a lot more powerful. I'm not going to go into all those details unless there's a specific question, but I am going to go ahead and use this first app. Before I actually use the app, besides I said you could favorite apps, but I'm going to click on the little info button, because that actually allows you to get a little bit of information about the app. So I clicked on it, there we go, and it will tell you a brief description. Often there'll be a link to a user manual, and back in tool information there'll be at least some information on the version, so where those apps are located on our system. To actually use the app, however, I just go back here and click on the app name itself. I'm going to close the app catalog. I don't need that right now. And back here I have a basic way that all applications in the discovery environment will appear. It'll be this sort of window with different menus that correspond to different steps that you need to complete. Back in analysis name, you can leave it as default, but I'm just going to go ahead and just add, March 2016 webinar. I want to leave comments. Okay. I also have the option for deciding where the output of my results will go. If I were, for example, working in a lab and I wanted everyone in the lab to put results of analyses in a shared folder, this is an example of where I would change it. In fact, I could go up to preferences and I could make that a default. When my app is done, by the way, I'm going to get email notifications, so I could decide whether I like that or not, but you get the idea. I'm not going to change any of these defaults. I'm just going to go to the next step, which is select input data. I need to browse for a file. Now this is going to thankfully open to the last place I opened a file from, which is right where I wanted it. So I'll choose DE sample plants and say OK. And then for sequence type, I'll go ahead and choose this as DNA, because that's what it was. I'll go ahead and click Launch Analysis. And I'll get a notification at the top that my analysis was successfully launched. Okay. I'll periodically get some type of a notification or status update. To actually see the progress in the history, I'm going to go down to Analyses. And from Analyses, I can actually see a detailed history of the jobs that I have launched. For example, I can see when they launched, when they've completed, what was the status. So right now my job is running. In fact, I got an update, so if I click refresh, it'll probably, well actually I missed one because it was submitted first and then it's running. So it's still running. If I want to actually see more details about an application, I can click on that application and go up to View Parameters. And then I see all the parameters that I used, which input was there, what the output is going to be. I can even click on a link directly to the data store, and that's the file that I used, or files. This can be pretty important when you have files that have number, letters, various alphanumeric names. You can see, let me select a different job that was more complex. If I go up and say View Parameters for that, you can see that this is really a sophisticated lab notebook. And I could even click Save As and export this as a simple text file. So I always have a history of my analyses. In addition to viewing the parameters of a completed analyses, back at the top here, I can stop an analysis that has already launched. Let's say I want to click relaunch, and what that will allow me to do is, rather than entering 20 different items and selecting a bunch of different things over and over again every time I want to do something, you can see that when I click relaunch, the app opens, in this case a Top Hat app, but all the options are just what I left them. So if I wanted to make an adjustment, I wouldn't have to adjust the 20 other things by starting from scratch. And I could click launch again, and that would go ahead and run again. Okay, going back to analyses, I saw that, let me refresh this, my muscle job is done. So I can click on the name of the job and it will navigate directly to the output. And directly from there, give it a moment to navigate through however many times I've done this. There are my output files, so I can click on that. And I should see, this time, instead of unaligned DNA sequences, I should see that they are aligned in file interleaved format. Okay. So really, any of the applications that you use within the discovery environment basically run like that. You find the application, you select the inputs, and you follow the step-by-step sort of wizard that the app launches, and then you launch it and can see the results. If there's an application that you like and it's not there, there are definitely ways to add it yourself. We are using Docker as a way to make it easier for people to introduce their own applications. There's a ton of stuff that I unfortunately just don't have time to show you, but many of it's already documented in the wiki, and we're always creating more documentation. But if you have questions now or you have questions later, the ones you have now I can try and answer. The ones that you might have later, we can talk about how to get additional help and support. Okay, so we have enough time for our final demo, which is going to be talking about using the Atmosphere Cloud. I have a couple slides just to introduce that, and then we'll go ahead and show you a quick demo of that. Okay, so Atmosphere. What is cloud computing and how does that work? As I said, it's a simple one-click access to hundreds of virtual machine images. You can really customize your software setup, and again, it's integrated with everything within CyVerse. First, though, since many of us don't use cloud computing, I want to introduce two terms that you'll need to know in order to understand. The first term or concept is an image file. Well, I like to use the analogy. Imagine you bought a new computer and now you need to transfer everything from your old computer to your new computer. Well, if you took individual documents, files, folders, photos, and moved them onto your new computer, well, first probably you put them onto a hard drive. But there's another type of file that you could actually make, and that file is called an image file. If you take an image file and put that onto a hard drive, that image file contains not only documents, data, but it contains the operating system, it contains everything down to your preferences, your wallpaper on your desktop, everything. So those documents, when you copy them off a hard drive, those are still documents, but an image file actually would really completely clone your new computer. So it's like a complete backup. It would restore everything. So that's what an image is. It's a collection of an operating system, data, everything. The other concept is an instance. So what is an instance? In the CyVerse cloud, we have hard drives, CPUs, memory, physical resources. And when you come to Atmosphere, you're going to ask us for a certain amount of those. So we're going to give those to you, the disk, CPU, memory, and you are also going to select from a catalog of images because your computer needs an operating system. And when you take the instance and you take the image and put them together, rather you take the resources and you take the image and put them together, you get an instance, which is a virtual machine. It exists at an IP address, and then you can connect to it, and it's really almost a disposable computer. When you come to use Atmosphere, you're going to choose an existing image or customize it. You can get up to 16-core, 128 gig machines. You can access it via shell or VNC, and you can share your image with selected users, even make them public. Let me show you how this works, then I'll come back to some of the benefits. I will also say, let me skip ahead in these slides, that to connect to it, you can use either VNC or the shell terminal. We'll talk about those things. Oops. Okay. So what I'm going to do is I'm going to go ahead and you can actually, from the CyVerse website, find also the link to Atmosphere. So that's the link there. And you can scroll down and there'll be a link to launch Atmosphere. Now I'm going to actually log out and log back into a test account where I have something running for us. I've already sort of staged it before. Or in fact, oh, it says I just need to log in this way. Let's see. Okay, let's log into this test account. Okay, now I am in Atmosphere. When I come to Atmosphere, it will give me a little bit of an idea of what resources I'm using, how many times I've launched particular instances, etc. But I'm going to go ahead and say Launch New Instance. And this is a catalog of about 300 images that are public, and they're tagged and described. So for example, if I wanted to do some RNA-seq, I could start typing in something like RNA, and I could see that there are various programs. So some of them are really nicely annotated in terms of what's on them, the software that's installed. But the key thing here is I didn't have to install any of this software. If you've installed software to run bioinformatics applications, you know that it can range from easy, just quickly download it and you're running it in 5 seconds, to I'm spending a week on this trying to find dependencies, etc. So with Atmosphere, you don't have to do that. Now, you would go through, let's say I wanted to launch this Trinitate. I could make sure the description is what I want. I could say go ahead and launch that, and it'll take me through a wizard where I name it, demo. I go ahead and continue. I can choose what size machine I need in order to do this. I may know offhand what I need, I may not. We can sometimes provide recommendations. You'll notice that I do have very clear allocations. In fact, besides the number of CPUs or gigabytes of memory I could use at any time, every single instance has a clock, essentially, a number of service units or Atmosphere units you can use. So if you exceed that, you're going to have to request more. I can put these instances into a new project. In fact, in Atmosphere, we are already organizing our resources by projects. And if I wanted to put in the test project and say launch, essentially I would click this last launch instance button and it would continue. Now I've already done this, so I'm not going to do it again. I'm just going to go to my projects. I have a project called UDEL, and I already have an instance that's running. It's got an IP address, so the next thing to do is connect to it. So I'm going to copy that IP address, and then I'm going to use a download called VNC Viewer, because this one happens to have a desktop. Not all of them will have desktops, but this one does. I'm going to paste in that IP address and enter :1. I'm going to ask, do I want to connect to it? Say yes. I'm going to enter my credentials. And hit enter. Okay, and I'm now connected to this remote computer. I can do anything with this computer that I would normally do on my desktop. I can go ahead and visualize things. As you saw, for example, in the discovery environment, if I had a program like RStudio, I wouldn't be able to run that currently in the discovery environment as a standalone program. Here on my Atmosphere, I can go ahead and run any type of software, any type of program that has a visual component. If I wanted to, through the VNC functionality, I could also give other users access to my Atmosphere, and we could visualize and work on things together. Now, I also mentioned you can connect via the terminal or via any type of SSH. I'm going to go ahead and start another shell that's easier to see on the screen. Zoom in here, and I could go ahead and say SSH, that IP address. In fact, let me have my user credentials. Hit enter, say yes, it's okay to connect, enter my password, hit enter. Let's do it correctly. My SSH, it's possible if I'm, try it one more time. I might have expired my credentials on that one, so I'm not allowed in by SSH. But please believe me, you just go ahead and connect through SSH and you'd be able to connect to that instance and then do everything that you would normally do at the command line. Although unfortunately, my credentials might have expired and I have to reset them. Not your fault, not mine, because they were working last week, but that's okay. But essentially, once you connect to it, you can analyze and also use this. So going back to the benefits and just sort of thinking through this for a second, what can you use this for? Well, keep in mind that you can configure the computer. So you can request resources equivalent to what would cost several $1,000s to just go ahead and buy a computer that you're going to use for a little while, and then most of the time it sits with most of that capacity unused. You can use it in the cloud. If you're doing analyses now that are monopolizing your desktop or your laptop, you can move those into Atmosphere. If you have, as I mentioned, graphically oriented programs, you could run them entirely on an Atmosphere image. You have sudo access, so you don't need to worry about anyone else installing things for you. You have complete administrative rights. If you're using this to teach or you use this in the lab, you could create your own custom instance or image so that everybody in the lab is working from a common computing platform with all the tools and data sets installed. And you can make your own software available to the larger community, so anybody can go ahead and have something image and post it up there. Okay, I have another question, which is, I found it difficult to get an instance with good resources. So this person is trying for 8 CPUs and 48 gigs of memory. So when you go back to the Atmosphere interface there, you'll notice, let's say on my dashboard, I have a certain amount of resources that are allocated to me right now. I'm not using very many. The caveat to Atmosphere is that, yes, you are limited by what's available at the moment. So at some times of the day or month or week, not every instance size is available to you. Now, there are better or worse times to do that, but unfortunately, at some point, the resources will not always be there. There are a couple of solutions to that. Number one, when we go into our instances and we have things running, it's really important for us that when we're not using something, that we either stop or suspend our instance, or when we're actually done with it, we really need everybody to go back and delete the instance. You have to be very careful about that, because when you delete the instance, everything that is on that instance, all data is destroyed. So you will need to have transferred data off your instance before you terminate it. In fact, when you start an instance itself, you need to bring the data on from your iPlant data store. Now, another solution, I'll go back to the CyVerse webpage, is that there's another project which is based upon the interface for Atmosphere. In fact, I think it's still featured here. It's called Jetstream. So this is essentially this one will take you to it, jetstreamcloud.org. This is essentially a really large cloud system that operates very much like Atmosphere. And I think it's going to be a little bit more predictable about what type of resources, and they have a lot more resources. So you would be also encouraged to seek out other resources like this if at any given moment you don't have what you need. However, that all being said, if you have some type of exceptional circumstance and you have a permanent need for hosting or other resources, you can always feel free, I'm about to talk about the help, to let us know, and we could see if there's a better way for us to be able to accommodate you so that you're not always stuck waiting for something. Okay, so quickly back to Atmosphere to wrap that up, and then also how do you get additional help from here. So back on Atmosphere, as I mentioned, when you are done using something, you're going to want to select your instance. And then once you have selected it, you're going to go ahead and you're completely done. You've moved that data off. You can go ahead and terminate it. And that returns those resources back to the community for their use. So I'm going to terminate that one. I no longer need it. Okay, so final slides and resources as we come up to the hour here is just about over. Okay, so the final thing is where to go from here. So we mentioned, please check out the iPlant Learning Center. They're getting started guides, tutorials, and documentation. Also check about upcoming events and workshops. I believe we're doing a workshop at Ohio State University next week, and that will also be available via live stream, so you can watch the entire 2-day workshop or whatever part of it you'd like. So please register for the live stream, and you'll be able to connect to that and see some of these things in more detail. We want to acknowledge the different sites, including the members of the executive team across those sites, and of course NSF support. And lastly, let me make sure I show you from the CyVerse homepage that you have the ability to get help. So if you go, besides all of these resources, if you go to the Get Help resource, there'll be important links. And including in those links, there's an Ask CyVerse. You just click on that. You'll see that certain things are still called iPlant, as I'm sometimes doing, but you'll see there's more than 1,000 questions. So many of these things may already have been answered for you, but you can post your question and the community will answer. We love it if you go here first to just check and make sure. There's only a small number of us, so if you can find out that your question has already been answered here, that's a great starting point. So with that said, I don't see any other questions. I'm going to allow just